call is now being recorded. Hello, everyone. Good morning, good afternoon, and good evening. This is Miss Kate, and for today's lecture video, we will be continuing our lecture session about malaria and babesia. So, for the last face to face lecture, we have already covered some of the basic concepts about malaria and established some of the fundamental information about the Plasmodium species. So, before we go further of our lecture topic and proceed to the PowerPoint presentation, please allow me to do some recall and recap about the life cycle of the parasite. All right, so let's begin at the very start. So it actually started with the female Anopheles mosquito. So if you have remembered, this female Anopheles mosquito is the primary vector of malaria. So unlike male mosquitoes which feed on the nectar, the female requires a blood meal to nourish their eggs. So this is where our story begins. So as the mosquito bites an infected human, it doesn't just draw blood. It also injects saliva. So if you have remembered my lecture, I have emphasized that this saliva contains a special property. So the saliva of the Anopheles mosquito contains an anticoagulant property to prevent the blood from clotting. And hidden within this saliva are the sporozoites. So this sporozoites is the infective stage or the infective form of the plasmodium. If you have remembered, these sporozoites are incredibly motile, so they are very incredible at finding their way into the bloodstream. So once in the blood, they travel through the circulatory system with one goal in mind. They need to go to the liver. So why the liver, by the way? So because the liver is a perfect environment for the parasite to grow and multiply. So it's like a hidden fortress where Plasmodium can safely develop and reproduce without being attacked by the immune system. So, once the sporozoites reach the liver, what happens next? They infiltrate what? The liver cells, which is also known as the hepatocytes. If you have remembered, your Plasmodium is an obligate intracellular parasite, meaning they need to be inside a cell to thrive and survive. So, inside the hepatocyte, this is where the parasite undergoes a dramatic transformation. If you have remembered, the sporozoites inside the hepatocytes would lose its apical complex, would lose its spindle shape, and become and transform to become the trophozoites. But class, take note that for Plasmodium vivax and Plasmodium ovale, they have a unique twist of their life story. So most of the strains of your vivax and ovale can enter a dormant stage. And this dormant stage is what we call as the hypnozoites. So at this stage, your Plasmodium vivax and Plasmodium ovale do not go yet and transform to become the trophozoites. Some of these species would undergo the dormant stage or the resting stage or the sleeping stage. And speaking of sleeping stage, hypnozoites are actually like sleeper cells. So they sleep, they remain in the liver, waiting for the right conditions to reactivate. So, what are the right conditions for it to be reactivated? So, if you have remembered, I have cited some series of example wherein if the patient's immune system is immunocompromised. So, say for example, the patient is suffering from autoimmune diseases or cancer, or if the patient is pregnant, or the patient is old enough. So these are some of the conditions wherein the hypnozoites will be reactivated. And this reactivation of the hypnozoites is what we call as what kind of infection? What we call as the relapse infection. So therefore, relapse infection again is very common to and applicable to Plasmodium vivax and Plasmodium ovale. So this is, by the way, particularly dangerous because it means that a person who has recovered from a malarial infection can experience a relapse months or even years later. So, say for example, the person is already treated with malaria, but eventually this patient DI have undergone dormant stage. So this patient experienced or some of the strains of the plasmodium undergone uh, a dormant stage. So this is particularly dangerous because it would only mean that the person who has recovered from a malaria infection can experience again the infection. So this is what we call as a relapse. So it could happen in months or or even years. So this dormant stages is most likely to occur when the immune system is again compromised. So it is actually a survival strategy of the parasite that allows the parasite to persist in the host even after the initial treatment. So this is how the parasite survives. So the parasites are really intelligent now in surviving. So this is the story of your Vivax and Novalis. So they have a different route of your life cycle. But then again, if your hypnozoites are reactivated, they would go further and proceed to become the trophozoites. Okay, so now let's move on to the next phase of the life cycle. So if these trophozoites right here, so if you remember, the trophozoites are the feeding stage, right? So those trophozoites would undergo the hepatic schizogony, which is your schizogony, or also known as your merogony. So this is the phase one of the life cycle. So your trophozoites would undergo hepatic schizogony, where it produces your hepatic schizons. You remember, right? So it would to become the hepatic schizons, and your hepatic schizons would divide and multiply. So what will happen again if your hepatic schizons would multiply? Eventually, your hepatocytes would burst. Your hepatocytes would burst, releasing what's inside the schizons again. So it would release what? It would release your hepatic merozoites, some books, daughter merozoites, right? So once um, once the merozoites are released, once the merozoite is released, it would move on to the next phase of the life cycle, which is the blood. So once the liver cells burst, they release the merozoites into the bloodstream, and then these merozoites are now ready to invade the RBCs. So in the RBCs, they need to find the right door to enter. Do you remember that one? So it the RBCs are not just passive targets for Plasmodium. They have receptors on their surface. So just like what I have shared to you. So these receptors are like empty chairs waiting for the parasite to sit down and invade. So these receptors are what we called as the glycopherins. You have remembered glycopherins. And they are very specific to different Plasmodium species. But there's a catch there. If you have remembered, we have this very Maarta parasite. So this parasite has a special requirement. Aside from the glycophorin receptor, your Plasmodium vivax has a special requirement. It needs a particular receptor called the Duffy antigen to invade the RBCs. So this means that individuals who lack the Duffy antigen are naturally resistant to Plasmodium vivax. So this is actually a genetic adaptation seen in populations in areas where malaria is very common. So this is part very rampant in sub-Saharan Africa. So where malaria is prevalent. So this is actually a way the human body has evolved its own defense against this parasite. So going back. So once the merozoites bind to the glycophorin receptors, they are able to enter the RBCs, and this is where the real action begins. So once inside the RBC, if you have remembered, the merozoites would transform again to become the trophozoites. Trophozoites. So the trophozoites, which are again the feeding form of the parasites. So these trophozoites are like tiny factories. They constantly break down hemoglobin because they feed on hemoglobin. So if you remembered what hemoglobin is for, so the hemoglobin is the protein responsible for carrying oxygen in our blood. So technically, your trophozoites would consume the hemoglobin to fuel their growth. Because remember, your trophozoites right here are the feeding stage, the active stage. They need to feed. So they need to feed on hemoglobin. However, the process doesn't stop there. So as the trophozoites feed, they create a waste product. So not all hemoglobins that they feed will be digested. So this undigested hemoglobin is what we call as what? Is the hemozoin. If you remember that one, the hemozoin, Hemozoin. So, hemozoin, when you observe that under the microscope, it is usually a dark pigment. That is why hemozoin is also known as the malarial pigment. So, it is a dark pigment and it is a hallmark. So, meaning it is a sign of a malarial infection. So, again, your hemozoin is essentially the undigested hemoglobin. So I will not write that down anymore since we have already covered that during the face to face. Okay, so hemozoin is your undigested hemoglobin that the parasite can't break down completely. So meaning dili niya makaon completely. Okay, so remember again that this pigment is very important for diagnosing malaria. And I want you to again differentiate this from malarial stippling. So in a blood smear, we can identify hemozoin in the RBCs. So again, as I have mentioned, your hemozoin are usually dark pigment, so yellowish brown. In most of the Plasmodium species, yellowish brown jud ang hemozoin. But again, it's important to distinguish hemozyne from malarial stippling. So stipplings, your malarial stipplings once again refers to the fine granular changes in the RBC cytoplasm. So meaning this is actually a proof that the cytoplasm is destroyed, is actually altered because of the parasite's activity or because of the plasmodium's invasion. So it is the subtle change of the RBC, that is your malarial stippling, unlike your hemozoin, which is the malarial pigment or the undigested hemoglobin. Okay, so it is not the same. Please take note. And if you have remembered, I have presented to you the different stipplings, malarial stipplings of the various Plasmodium species. Diba? Remember that one? Vilma Santos, Ferdinand Marcos, Manila Zoo, orange juice. Diba? So, I think you have remembered that one. The Morers cloths, Scuffner's dots, the James dots, what else? Mm, Scuffners again for the no lessee. So I have already presented that to you during the face to face. So this is just an emphasis that you need to differentiate again your malarial pigment from your malarial stippling. Okay? So in here, as going back to the life cycle, as the trophozoites mature, they turn into schizons. This time, we are referring to the erythrocytic schizons. So, this schizons is the stage. This is the stage where the parasite undergoes asexual reproduction. So, if you have remembered, this process is what we call as the schizogony. And specifically, since we already entered phase 2, this is what we call as the erythrocytic schizogony. Schizogony. Okay, just remember that your phase one is your hepatic schizogony, and for your phase two, we are referring to your erythrocytic schizogony. Okay, so for this process, this is where the parasites really multiply up to its numbers, so it multiplies a lot. So the schizons right here, they divide rapidly, producing dozens or even hundreds of new schizons. And if you have remembered, in each schizon there are actually merozoites inside. So if the schizons divide rapidly, it also produces dozens or even hundreds of new merozoites. Okay? Again, so if you have remembered, this happened all inside the RBC. So what will happen if it divides and multiplies? Your RBC would burst. So if your RBC would burst or would lyse, it would release your merozoites. What we call as, we specify that one, erythrocytic merozoites. Erythrocytic merozoites. Okay, so these are your merozoites. So the merozoites are then released when the infected RBC bursts. So every time an RBC would burst, the patient experienced fever paroxysms, if you remember that. So it is, your paroxysm is a cyclical pattern of sa ganito, chills, high fever, and sweating. So we have the cold stage, that is phase 1. We have phase 2, which is the hot stage, and we have the sweating stage, which is the last stage. Again, every time an RBC would burst, releasing the merozoites to the system, the patients experience fever paroxysm. So again, this fever paroxysm is a cyclical pattern of chills, high fever, and sweating. So, meaning we have the cold stage, we have the hot stage, and we have the sweating stage. So, this is actually the body's immune response to the release of merozoites and the destruction of the RBC. But here's the thing, class. If you have remembered, I have emphasized that your Plasmodium falciparum is particularly dangerous because it can complete 5 to 10 cycles of schizogony in a single day, meaning some of the erythrocytic merozoites would re-enter RBCs, would re-enter another RBCs and began evolving or producing again the trophozoite schizons and bursting another set of RBCs. And this is what we call as the intraerythrocytic life cycle or the intraerythrocytic schizogony. For Plasmodium falciparum, your Plasmodium falciparum undergoes intraerythrocytic schizogonies 5 to 10 cycles. So again, balik-balik. So say for example, your when your schizons right here would burst, diba, RBC would lyse, it would actually release your erythrocytic merozoites. So every time your RBC would lyse, erythrocytic merozoites would be released. Some of the merozoites would re-enter, would reinvade another set of RBC, and the cycle happens all over again. And that cycle is what we call as intraerythrocytic life cycle, and that is very common to Plasmodium falciparum. So it can complete 5 to 10 cycles. So this means that the parasite can overwhelm the immune system. So if you have remembered, every time that the RBC would burst, the patient would experience fever paroxysm. So what will happen to the patient? So that this would only mean that the parasite can overwhelm the immune system of the patient faster, leading to severe symptoms and some complications. So that is why if you read on your books, the fever paroxysms you see in Plasmodium falciparum infections are intense, and the constant reinfection of the RBCs, pagbalik-balik niya og reinfect to RBCs, makes it very difficult for the body to recover. Okay? So that is what we call as the intra-erythrocytic life cycle or schizogony. Intra-erythrocytic schizogony. So, but not all of the merozoites would be doing that. This is just very common to Plasmodium falciparum. Most of the strains or most of the species of your Plasmodium would undergo the final stage in the human life cycle. Instead, that they would reinvade another RBCs, they would undergo the process of gametogony. So in here, some of the erythrocytic merozoites would transform to become the trophozoites, and these trophozoites will no longer mature to become schizons. So they would undergo the sexual phase of the parasite's life cycle, and that would be the gametogony, which is the phase 3 of the human life cycle. So these trophozoites would now become gametocytes, would transform to become the gametocytes. Okay, so this is where the um, ending would happen in the human life cycle. So this is when for Plasmodium falciparum, this is when the parasite census, diba, if you remembered, Plasmodium falciparum enters an intraerythrocytic life cycle wherein the erythrocytic merozoites would reinvade another RBCs. But when the parasite gani, when Plasmodium falciparum senses that the host is being treated with anti-malarial drugs, it really knows that it's in trouble. So it knows that it's in trouble, so it stops multiplying and it switches its gears to produce gametocytes instead. So for most of your Plasmodium species, most of your Plasmodium species would undergo gametogamy automatically. So most of them would not undergo the intraerythrocytic life cycle anymore. So this is where the male and female forms of Plasmodium would be produced. So these gametocytes, just take note, don't cause any symptoms in the human host. But they are very crucial for the mosquito's life cycle. So take note that humans who carry gametocytes are asymptomatic carriers. So they're asymptomatic carriers, meaning they may not feel sick, but they can still infect mosquitoes. And it is important to note that while these gametocytes are in the human bloodstream, they are not infecting the human host. So meaning they remain as asymptomatic carriers. So they are simply waiting for the mosquito to come along. So this is actually the end of the the human life cycle, but the gametocytes right here triggers the start of the mosquito's life cycle. So the circle of life continues. So let's return to the mosquito. So when a female Anopheles bites an infected human, it ingests what? The gametocytes, right? So these gametocytes, these gametocytes are there for the infective stage. This is the infective stage of the female Anopheles mosquito. But here's the twist. The mosquito needs to ingest at least 12 cubic millimeters of blood to become infected. So they need to have an infective dose. We call that as an infective dose of 12 cubic millimeters of blood to become infected. So once inside the mosquito's stomach, the gametocytes mature. So the female gametocytes become macrogamete. Again, in parasitology, female parasites are usually larger compared to the male parasites, larger in size. So the male gametocytes undergoes exflagellation, and that is a process where it actually produces to become several microgametes. So again, your macrogametocytes would undergo maturation. This is, by the way, the female macrogametocyte, the female form, and it will now become your macrogametes. Sorry, your macrogametes. Your macrogametes would now. Oh, okay. Right. So while your many here, just while your microgametocyte right here, my microgametocyte would undergo the process we call as exflagellation. So this is a process where it produces microgametes. Again, take note that your mac- microgametocyte is the male form. Okay, so that is your microgametes. So therefore, class, the macrogametes and your microgametes meet and fertilize, forming a zygote. They would actually form to become a zygote, and the zygote then transforms to become an ookinete. An ookinete is a worm-like structure that travels through the mosquito's stomach wall. So, ookinete is also known as your traveling vermicule. And so it's like a worm. So it would travel. So it would travel through the mosquito's stomach wall. So once it reaches the outer lining of the mosquito's stomach wall, it would secrete a cystic wall and it would now become the oocyst. So this oocyst would undergo sporogony. So this is a process of rapid division that produce your sexual forms, and that would be the sporozoites. So this, when your oocyst undergoes the process of sporogony, it would multiply and eventually it would burst, releasing sporozoites. So these sporozoites would travel to the mosquito salivary gland where they are ready to be transmitted to a new human host. And just like that, the cycle begins again. Okay, so this is just a summary of the Plasmodium life cycle, which we have discussed in our face-to-face session. Um, I did purposely recall or discuss this all over again since we will be needing this basic knowledge when we discuss some of the specific stages of the parasites morphologic stages later on and its um, pathophysiology. Okay, so I will stop my lecture video here and I will be proceeding to the next lecture session or lecture video. All right.